Hello everyone, welcome to the Module 1 of Climate Change course. In this module, you will learn about the Earth climate system. I believe everyone knows that the Earth is the only planet in our solar system that is very abundant in water in all three forms, including gas, liquid, and solid. And it is also the only planet that is very rich in biodiversity. So if we look into our solar system, we could see that the inner planets such as the Mercury and Venus are too close to the Sun, so they receive too much energy that make them too hot for the organism to exist. While the other planets such as Mars and others are too far, they receive too little energy, which make them too cold and too dark that doesn't support life either. On the other hand, the Earth located just in the right distance from the Sun. It receives just enough amount of energy that is necessary for biodiversity development. But this is not the only factor that makes our Earth a Goldilocks planet for life. The other important factor is its own climate system that regulates and maintains energy balance through the entire system, which makes the Earth environment very unique and livable. So in general, in this module, you will learn about the anatomy of the Earth climate system, which include the primary component of the system and also the interaction among those components. So by the end of this lecture, you should be able to first define what the Earth climate system is, then describe in detail about each of the primary components, and also explain how those components interact and influence on our global climate system. So, before we begin to dig deeper into the topic, I would like you to think a little bit. What does the word climate system mean to you? Well, as defined by the International Panel on Climate Change, the climate system is defined as a highly complex system consisting of 5 major components, including the atmosphere, the hydrosphere, the cryosphere, the lithosphere, and the biosphere, as well as the interaction among those components. So naturally, the climate system evolved in time under its own dynamic and external forces, which include volcanic eruption and solar radiation, and also the anthropogenic activity that may cause change to the characteristic of its own component. In this diagram, you can see all the 5 major components of the Earth climate system and also the pathway that each component can interact with each other. So both the Earth's surface is the atmosphere, which extends from ground level to about 500 km up into space. Then you have all the liquid water system, including ocean, river, lake, and raindrop, that represent the hydrosphere, which is continuously moving and interacting with the surrounding environment. Then you have the ice cap on top of the mountain and the ice sheet both on land and water, that represent the cryosphere. Then the mountain range and land area represent the lithosphere, or sometimes called the geosphere, that contain all types of the Earth crust material. The tree, building, and car represent the existence of human beings and other living organisms which are part of the biosphere. So these 5 components of the climate system are constantly changing and influence each other in many ways, which we will discuss about it in detail in the next 10 minutes. Now let's take a look at the Earth atmosphere, which is the most sensitive component of the Earth climate system. The atmosphere can be considered as the blanket that covers around the Earth, keeping the Earth's surface warm enough for us and other organisms to survive. It is made up of a mixture of different gases with different proportions, and is divided into 5 different layers, including the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. The major gases that made up of our Earth atmosphere are the nitrogen gas, and the oxygen gas, which account for about 78% and 21% of the total atmospheric mass respectively. The remaining 1% is some trace gases, which include some inactive gas and greenhouse gases. Trace gases in the Earth's atmosphere contain the rare gas species such as argon, neon, helium, xenon, and the greenhouse gas like water vapor, carbon dioxide, methane, nitrous oxide, ozone, and the chlorofluorocarbon family. The presence of this greenhouse gas in the Earth's atmosphere play a very important role in trapping heat to keep the Earth's surface temperature warm. Without the warming effect of greenhouse gas, surface temperature of the Earth would be deadly cold for human beings and many other species. So we can simply say that without the presence of greenhouse gas and its warming effect, biodiversity on Earth would not exist. The other important aspect of the Earth's atmosphere is that the amount of gases are not evenly distributed throughout the atmospheric layer. So the temperature and other characteristics also vary from layer to layer. For example, as you can see in this figure, in the troposphere, the temperature decreases gradually as we move upward. However, in the troposphere, a layer immediately above it, the temperature increases continuously as we go higher and higher. This is because the amount of ozone is much more concentrated in the stratosphere, which allows it to trap more heat compared to that in the troposphere. So we will talk more detail about these differences in the next several slides. Okay, now let's start with the troposphere. The troposphere is the lowest layer of the Earth's atmosphere. It lays from ground surface up to about 10 km on average. However, this upper boundary can vary significantly according to the latitude and season. In general, it is lowest at the polar region and highest along the equator. Also seasonally, it is lower in winter and much higher during summer period. The troposphere is the most dense layer of the Earth's atmosphere. It contains about 75% to 80% of the total atmospheric mass. This is because it is the nearest layer to the ground surface. So, due to the strong gravitational force of the Earth, any particles that are released from ground surface will accumulate in the troposphere before they can escape to other layers above it. The troposphere is also the wettest layer of the Earth's atmosphere. This is because this layer stays in closer contact with all sources of water on the ground, including the ocean, lake, river, and also the frozen water system. So naturally, it has higher moisture content compared to other layers. The air temperature in this layer is generally warmest at ground level and getting colder as moving outward. And because the troposphere is directly in contact with ground surface, its composition and characteristics are strongly influenced by the activity that occur at the ground level, including the natural phenomena such as volcanic eruption and the man-made stresses such as emission from industry and transportation activity and so on. The layer immediately above the troposphere is the stratosphere. It lay between 10 km to about 50 km above ground level. In this layer, the ozone gas is relatively abundant. Therefore, much of the sun energy is absorbed here, causing the air temperature to increase with latitude. Because of this warming effect, air temperature in the stratosphere is remarkably stratified, which makes vertical mixing phenomena very uncommon in this layer. So resultantly, any material that enters the stratospheric layer tend to stay there for quite a long period. This sometimes causes damaging effects on the ozone layer. For instance, the chlorofluorocarbon gas molecule, which released from human activity at the ground level, can stay in the stratosphere, interacting with ozone molecule, causing ozone layer to break in some region, which is not good news for us. as ozone layer play an important role in blocking short-wave solar radiation that can have negative effect on our health and environment. Because there is not so much moisture content, the air in the stratosphere is relatively dry. Therefore, very few clouds are formed in this layer, except the polar stratospheric clouds which appear near the polar zone in winter. So the atmospheric layer above the stratosphere is called the mesosphere, which lay between 50 km to 80 km above ground level. Very little is known about this layer because it is very difficult to study. Somehow, scientists had discovered that in this layer, the ozone level is very low, so very little solar radiation is absorbed here, which leads to temperature decrease throughout the entire layer as moving upward. Furthermore, because very little sun energy is absorbed in this layer, the mesosphere is generally very dark with very low temperature that human beings cannot survive. Another characteristic of the mesosphere is that meteorites from space are mostly evaporate in this layer, making it to have high concentration of iron and other metallic atoms. The layer just above the mesosphere is called the thermosphere. It lay between 90 km to about 500 km on average. This layer is strongly influenced by the solar activity. The temperature in the lowest part of this layer increased sharply, then leveled off when it reached the altitude of about 300 km, then remained steady as moving upward. The air temperature at the uppermost of this layer can be as hot as 500 degrees Celsius to about 2000 degrees Celsius. Air density in this layer is very low as it is almost in the outer space of the Earth's gravitation. Most of short-wave radiation such as UV and X-ray are absorbed in this layer of the atmosphere. The uppermost of the Earth's atmospheric layer is called the exosphere. It lay from about 500 km above ground upward and gradually fade into outer space of the Earth. The air in this layer is generally very thin as it contains only hydrogen and helium. Furthermore, some small portion of the Earth's atmosphere leak into outer space in this layer due to the lack of Earth's gravitational force, as this layer is very far from the Earth. Now let's take a look at another component of the Earth climate system, which is the hydrosphere. The hydrosphere refers to the total mass of water. This includes water in all the three forms, gas, liquid, and solid. Although the solid form of water has its own name called the cryosphere, which we will discuss about it separately in the next few slides. So as a matter of fact, water is very important substance that support life on Earth. Globally, water covers about 70% of the Earth's surface. This water is home to many plant and animal species and provide benefit to all organisms on Earth. So without water, there will be no life. As part of the climate system component, water can play important role. As part of the climate system component, water play important role in regulating global weather and as a cooling engine for the regional climate. So all the water in its liquid form are the component of the hydrosphere. This includes the salty water of the ocean and sea, which is account for about 97% of the total water on Earth, and the freshwater system, including surface water, groundwater, glacial water, and the atmospheric water in the form of water vapor. As I mentioned earlier, water in the hydrosphere is very important regulator of the Earth climate system because water never stays still. The water molecule always moves through the hydrosphere in a cycle called the water cycle or the hydrology cycle. The overall mechanism is that water in the atmosphere in the form of water vapor collected as cloud, then in the right condition they condense and fall into the ground in the form of rain and snow. Then this falling drop of water collects in river, lake and ocean, then go back to the atmosphere through a process called evaporation to start the cycle over again. Given that heat capacity of water is very high, The change of water molecule from gas to liquid and to solid form through this continuous water cycle can act as a cooling system that regulates global climate pattern. In addition to this, the movement of water in the ocean can also strongly affect global climate, especially in a larger time scale, which we will discuss in detail about this issue in the module 2. Now let's discuss about the cryosphere. The cryosphere refers to all solid form of water on Earth. This includes sea ice, snow cover, glacier, ice cap, ice sheet, and also frozen ground such as the permafrost. So globally, around 10% of the Earth's surface is covered by the glacial ice, which is approximately around 15 million square kilometers, including the ice sheet of the Greenland and the Antarctica. So the glaciers store about 69% of the world's fresh water. With this enormous amount of water storage, if all land ice melted, sea level would rise approximately 70 meters around the world. As part of the climate system, solid water or the cryosphere play an important role in regulating the global climate and energy balance. Because snow and ice have very large albedo, they reflect the majority of the incoming solar radiation back into space, keeping the temperature at the ground level cooler. On the other hand, the ice sheet also a good insulator that reduces the amount of heat loss from the underlying surface of land and ocean toward cold atmosphere in winter, which help to sustain life of many species during the winter time. In addition, ice sheet also act as a regional cooling engine that regulates global climate patterns. Now let's take a look at the lithosphere. The lithosphere, or alternatively we can call the geosphere, consists of the earth crust and the outermost of the solid mantle of the earth. It consists of the rock material and other mineral composition. And as part of the Earth climate system, the geosphere interacts with other components such as the atmosphere, hydrosphere, and cryosphere to influence the Earth temperature difference. For example, the mountain range of the lithosphere can interact with the lower air pressure of the atmosphere and also the snowy precipitation of the hydrosphere to create a cool or even icy climate zone. Similarly, rock material and other composition of the lithosphere can undergo atmospheric weathering phenomena, leading to a change in ocean water characteristics, which consequently affect global climate pattern in a large time scales. How about the biosphere? The biosphere, or sometimes called the ecosphere, refers to everywhere that life exists and all life forms, including human beings, plants, animals, and other organisms. The biosphere extends from the deepest root system of the tree to the dark environment in the deep ocean trench to the lush rainforest and also the high mountain tops. The biosphere interacts with other components of the climate system in many ways. One of the most obvious examples is the human activity, which generally affects more than one component of the Earth climate system. For example, urbanization of human society have led to tremendous change in land cover pattern, affecting land surface, which is part of the geosphere, and consequently contribute to the variation in the amount and types of gases emitted into the atmosphere, which can trigger change in our global climate. Aside from human activity, the characteristics of the biosphere itself can also significantly affect the Earth climate, as it has direct impact on the Earth energy balance. The vegetation present on land has a critical influence on climate at all spatial and temporal scale, because vegetation areas usually have lower albedo than bare soil and snow. So in general, the vegetation area absorbs more solar radiation than other types of coverage. As you can see in this figure, the forest area reflects only about 10 to 20% of the incoming solar radiation, while the other coverage areas such as snow cap reflect about 80 to 95%, and the brick and stone cover area reflect about 20 to 40%. The presence of vegetation area also improve evapotranspiration process because the area that covered with trees usually hold higher water storage than other regions. The terrestrial biosphere, which include all types of inland vegetation and other species, play a critical role in global carbon cycle, which has a strong influence on the amount of carbon dioxide that released into the atmosphere. So now we have reached the end of the module 1, and I believe that more or less you have learned about our Earth climate system, including its primary component and their interaction among each other, which is an important factor that makes our Earth environment favorable for living organisms, including ourselves. So in the next module, we will discuss in detail about the physical process that govern our global climate pattern.